Hello and welcome to another digital design class. In the previous class, we discussed the K-map. We solved some problems for 3 variable K-maps and 4 variable K-maps or Karnaugh maps, and also 5 variable K-maps. And this week we will continue with using K-maps or Karnaugh maps to solve the product of sum and to simplify product of sums. So we learned that we have the sum of products. We call them SOPs. And we also call them minterms, and we write them like x prime, y prime, z prime. This is a minterm. And we have the product of sums, or POS, or the max term, which is like x plus y prime plus z prime, something like that. From the De Morgan's theory, we already know that f is equal to f prime prime. So if we invert an inverted function, we get the actual function. So if f is the product of sums, f prime would be sum of products. Or if f is sum of products, f prime would be product of sums. And we also learned about duality in the postulates from Boolean algebra, which we can combine the max terms. So it's a combination of max terms. And one example that is mentioned here, it's M0, M1 would be equal to A plus B plus C plus D times A plus B plus C plus D prime gives us A plus B plus C plus D D prime, which gives us A plus B plus C. Now we can use these two approaches to solve a system for the product of sum form and for the sum of product form as well. Now, the best way to learn this actually is to learn it through an example. So let me start with an example. Imagine, by the way, we have the Karnaugh map is going to be the same as we had as before. We have 4 variables, A, B, C, and D. And again, we're going to have M0, 1, 3, 2, 4, 5, 7, 6, 8, 9, 11, 10, 12, 13, 15, and 14. So this is going to be A. This is D. This is B. And this is C. Now, let's solve for an example of simplification using the sum of product form and the product of sum form. We already learned about the sum of product form, so I'm going to leave that part to you. I'll give you a few minutes to think on it and find the sum of product. And in the meanwhile, I'm going to draw the table for it. So this is going to be the, again, Karnaugh map or K-map table. And we have A, B here, and C, D here. Again, this is going to be A, D, B, and C. This is M0, 1, 3, 2, 4, 5, 7, 6, 8, 9, 11, 12, 13, 15, and 14. And whoever gets the sum of product first gets an extra point on their first, on their next homework. Okay. So 0, 1, according to the function that we have, 0, 1, 2, 5, 10, 9, 8. These are our ones. So 0, 1, 2, 5, 8, 9, and 10. So if I want to find the sum of products, I have to combine the ones. The easiest way, the best way to do it to get the minimal amount of terms is going to be to combine the 4 in the corners. If I combine these 4 in the corners, f, this is equal to b prime d prime. And I can combine these two together. If I combine these two, it's going to be equal to plus c prime. You start with the a prime, c prime, d. And the next one that I can do, which to make it easier, is to combine this one with these 4, the other 3. And the green one would be equal to b prime, c prime. Yes, it's going to be equal to b prime, c prime. So f would be equal to b prime, d prime plus a prime, c prime, d plus b prime, c prime. Now, the easier way to find the product of sum, we already know that the product of sum is SOP prime. It's the complement of the sum of product. The product of sum is the complement of sum of product. In other words, for example, x prime, y prime is going to be equal to x prime prime plus y prime or x plus y. So in this function, these numbers, the sigma shows us our ones. F prime should show us what? Our max terms, which are our zeros. The zeros are the complements of the ones. So what I'm going to do, I'm going to fill the rest of the tables with the zeros. Okay. Now I'm going to combine the zeros together. So I can combine these 4 zeros. Let me do it with a different color. Let me do it with green. So I'm going to combine these 4 zeros together. I'm going to combine these 4 zeros together. And I'm going to combine these 4 zeros together. So for the first one, and this is going to be, by the way, f prime is going to be equal to CD plus the second one is going to be the one in the row in the bottom is going to be equal to AB plus the 4 in the corner are going to be equal to BD prime plus BD prime. So to find the sum of products, we will combine the ones. To find the product of sums, we will combine the zeros. And if I find the f prime for this, the f prime would be exactly the same. And you can check that as well if you want. You can find it. And if you apply the De Morgan's law, you can find it. So if I apply the De Morgan's law for the second one, therefore f would be equal to C plus D or let's make it like this, I'm sorry. If I apply the De Morgan's law to this one, so f is equal to f prime prime is going to be a prime plus b prime. Right, let me do it somewhere that I have space. So f is going to be f prime prime. So if I want to find the f prime prime, it's going to be a prime plus b prime times c prime plus d prime times b prime plus d. Now let's find the solution to this. F is equal to f prime or prime prime. So if I multiply these two together, the first two, I'm going to get, if you wrote it down, can I erase this so I can continue this? Okay. Is it okay? Okay, thank you. So I want to solve for this. Let's solve this. So a prime c prime plus a prime d prime, a prime c prime plus a prime d prime plus b prime c prime plus b prime d prime. And all of that again multiplied by b prime plus d. So if I multiply these by b prime d, I'm going to have a prime c prime b prime plus a prime d prime b prime plus b prime c prime b prime B prime, C prime, B prime, plus B prime, B prime, D prime, plus, now this, we want to multiply everything by D, A prime, C prime, D, plus A prime, D prime, D, plus B prime, C prime, D, plus B prime, D prime, D. What is D multiplied by D prime? 0. So this is 0. This is 0. And what is B prime times B prime? It's equal to B prime. So this is going to be equal to B prime C prime. This is going to be equal to B prime D prime. And so on. Now, I can factor out these two, combine them together. I'm going to have A prime C prime times B prime plus D. And I can do it again and again. And I don't have enough space to continue it here, but if you simplify this, you're going to get eventually to the one on the top. You're going to get to the upper one. Okay? This is just a proof. I just wanted to show you a proof that if we simplify all of that, you can see we already got B prime C prime. We got B prime D prime. Where is it? Yes, B prime D prime. So we have, and if we simplify all of that, we get to A prime C prime D prime D. So to simplify a function into the sum of products, we will combine the ones together. And to find the product of sums, we would combine the zeros together. And each of these are the complement of the other, according to the De Morgan's law. Now, if we want to get the implementation of the function on using logic gates, we would simply replace the ands with ors and the ors with the ands. So here on the left side, f is equal to B prime D prime plus B prime C prime plus A prime C prime D. And the product of sum is A prime plus B prime, C prime plus D prime times B prime plus D. And you can see the difference between them is the ands have become the ors and the ors have become the ands. And again, these two are going to be the exact complement of each other. Okay. And the inputs, obviously, A becomes A prime, B becomes N, and so on. Everything switches. Now, let's solve it using a truth table. We want to do the sum of minterms procedure and the product of sums. Consider the function defined in the table. In this table, we will look for the ones. The ones gives us the sum of products. So these ones are all SOPs, SOP, or sum of minterms. And the zeros, they gave us the product of sums, or POS. So the ones that I marked with blue are our sum of products. So it's going to be 1. This is 1. By the way, 0, 1, 2, 3, 4, 5, 6, and 7. So it's going to be 1, 3, 4, and 6. These are the sum of products. And the red ones, which are 0, 2, 5, and 7. So you can see the sum of product is 1, 3, 4, 6, and the product of sums is going to be the multiplication of 0, 2, 5, 7. So the product of sum and the sum of products are the complement of each other. If we have ones, it's the sum of product. If we have zeros, it's the product of sums. And taking the complement of f prime, we can see we get x prime plus z prime times x plus z. And I will show this with a table so you would better understand. So we will consider the function defined in the previous table, 3, 2. And in that table, sigma of the 1, 3, 4, 6. So 1, 3, 4, 6 were ones. 1, 3, 4, and 6 were ones. And 0, 2, 5, 7 are zeros. 0, 2, 5, 7 are zeros. So 0, 2, there's a typo here, missed the 0. Let me do it black. So 0, 2, 5, and 7 are zeros. Again, f, oh, okay, my pen stopped working for some reason. F is going to be equal to sigma of 1, 3, 4, and 6. And f prime would be the multiplication of 0, 2, 5, and 7. Now, if we want to find the sum of products, we will combine the ones. And if I combine the ones, we would have, it's already been highlighted. So it's going to be these two combined. These two combined gives us x prime z. And these two combined gives us x z prime. And to find the product of sums, we will combine the zeros. I could combine these two together. If I combine these two together, I would get x prime z prime. And I could combine these two together. If I combine the two in the middle, what do I get? X z. So f prime of x would be xz plus x prime z prime. Now, let me give you another example. For the following function, f is equal to xyz plus x prime y prime z prime plus xz plus yz. I want to find the sum of products and the product of sums. Let me give you the table as well so you can. So again, f is xyz plus x prime y prime z prime plus xz plus yz. Oh, this is a 4. Let me give you a 3 variable. Table. By the way, you have to memorize these because on the FE exam, for example, or in your exam, you don't have time to search for it. Sometimes they don't give it to you at all. So it's better to memorize this.
So that F is equal to that expression there, that is already the sum of products, correct?
Yes.
Okay.
Yes, exactly. But we can minimize it. Okay,
Gotcha, yes, sir.
we can minimize it still. You can simplify it. I'll give you again 5 minutes to think on it. So the better way to for the question is we want to simplify the sum of product and product. Find the simplified sum of product and product. I would solve it. Yes, it's yeah, somehow correct. I mean, you need to find the POS as well, the product of sum.
How would you do that?
You fill the rest of the table with the zeros and then combine the zeros. Yeah. Did everyone solve it? Can I? So x, y, z is 1. So this is 1. X prime, y prime, z prime is 1, which is the one here. And then we have x, z. So x, z are going to be these two. And we have y, z. So y, z are going to be these two. Did you get the same? Yes? Okay. X prime, y prime, z prime. Gonna draw it with, yeah, let's draw it with black. Now, if I want to find the midterms, sum of products, I will combine the ones together. So I have 1, I have this, and I have this one by itself. So these two, it's going to be equal to xz plus yz plus x prime, the third one, x prime, y prime, z prime. So by simplifying it, you just get rid of the first term, x, y, z. So the SOP f would be xz plus yz plus x prime, y prime, z prime. Now to find the product of sums, I would fill the rest of the table with the zeros, and then I will combine the zeros together. So I can combine these two together. I can combine these two together. And this one, I can't combine it with anything, so it's going to be on its own. So f prime, or the product of sums, is going to be equal to yz prime plus xz prime plus x prime y prime z. Now the next one that we have is, and by the way, if I want to find the products of sums, the POS, I can simply convert this and to the product of sums and find the answer for, if I wanted to write it in max terms. So for the don't care, we have another condition as well. It's called the don't care condition. So what does a don't care condition mean? Don't care condition means that we don't care if it's 0 or it's 1. And sometimes it's not 0 nor 1. We just show it with the x. And we don't care if it's a 0 or a 1 or x. One example is for BCD numbers. We know that BCD numbers are between 0 and 9. So we know the BCD numbers are 0 to 9. So number 10, which is 1, 0, 1, 0, and up to 15, which is 1, 1, 1, 1, 10 to 15. This could be allocated as X or don't care. Because we may have this number, but it doesn't make any sense. It doesn't mean anything in a BCD. But the good thing about the don't care condition is that it could be utilized to simplify our function, to minimize our logic function. And as mentioned, it could be implemented as zeros or ones. And let me give you, I will give you some examples. So first example, we want to simplify f is equal to f of w, x, y, z is equal to 1, 3, 7, sigma of 1, 3, 7, 11, and 15. These are our ones. These are the sum of products. And the don't care conditions, we show it with the d, or don't care, of w, x, y, z is sigma of 0 to 5. Let me write it here. So zero, 1, 2, 3. Oh, this is another example. Yeah, let's do it for this. So let's first draw the Karnaugh map table or the K table. And we will fill the table again. This is 0, 1, 3, 2, 4, 5, 7, 6, We want to skip the third row and I don't know why it's going to be 8, 9, 11, 10, 12, 13, 15, and 14. And by the way, this is our W X, and this is YZ. Now, number 1, 3, 5, 7, 11, and 15, these are ones. So, and the don't cares that we had are 0 to 5, 0, 2, and 5. And as mentioned here, the don't care, the reason that we got rid of this, because the don't care can be 1 or 0 as well. So if it's overlaps with 2, it's okay. We can just assume it's 1, or number 2 is 1, or it's don't care. Again, let me go back to the previous slide. So we see that the don't cares are 0 to 5. So I'm going to fill 0, 2, and 5. Can do it with X. Now, the don't care, if I can reutilize it, I will utilize it to simplify my function. So I'm going to add the don't cares of 0 and 2 to simplify this. And by the way, this is W, Z, X, and Y. So if I combine these 4 together, what I get is equal to W prime X prime, or X prime W prime. And then I can combine these 4 together, and I would get Y, Z. So F would be equal to W X prime W prime plus Y, Z. Let me give you another example. Imagine we have a function F is equal to the sigma of 0, 1, 2, 3, 5, 7, 12, 14, and don't care of 6, 8, and 9, and 10. We want to find the simplified version of F. Again, if I draw the table, let me draw the table for you. Zero, 1, 3, 2, 4, 5, 7, and 6, 8, 9, 11, and 10, 12, 13, 15, and 14. I will give you a few minutes to think on this, and I would solve it. I think it's correct, yes. Yeah. Great. Okay. So first I will replace the ones. So 0, 1, 3, and 2, 5, 7, 12, and 14. These are the ones that we have. And I'm going to put the zeros with the green. We have 6, 8, 9, and 10. Oh, sorry. You don't care. So 6, 8, 9, 10. So 0, 1, 2, 3, 5, 7, and 12 and 14 are the ones. And 6, 8, 9, and 10s are the don't cares. Now, we must see which ones we can utilize. Obviously, we will start with these 4 ones. If I combine these 4 ones, F would be equal to W prime Z with these 4 ones, plus I can combine these 4 ones as well. And if I combine these 4 ones, I would get X prime W prime plus. Now, I can utilize this number 6 and 10 and combine it with the one on the upper part and do it like this. If I combine these 4, I would get Y Z prime. And finally, I can combine these 4 ones together as well. If I combine them, it's going to be equal to Z prime W, or WZ prime.
So with the don't care conditions, do you have to consider them
No.
as ones that?
Yes, that's a great question. This one we didn't even consider. So we can utilize it if it's useful. If it's not, we can just ignore it.
Why Z prime doesn't have?
Which YZ? Y Z prime? Yeah, the blue one. We want. Why?
Well, so what I did is.
Yes, you can technically, yeah, you can get rid of that. But I just wanted to show you how it's done. And if you simplify, you would simply see that this one would go away. Thank you for bringing that up. But yeah, this one, if you combine it, it's going to just go away. But I just wanted to show you how we can combine these 4. If I didn't have a 1 in number 12, I would just have YZ prime, okay? Or let's make it simpler. Let's change 12 to 13, and you would see I can just combine them together. But yes, technically you can just ignore. And when you simplify it, you can see it's just going to get out. But I just wanted to show you how we can combine X or we can just ignore them, okay? Yeah, if I didn't have number 12, I would just do Y prime. But here it's going to be Y prime Z plus X prime W prime, I'm sorry, W prime Z plus X prime W prime plus WZ prime. And this is the answer to the previous question that we had, that we solved. Again, you can see that we can utilize the don't care in different ways. I can do the 4 on the top, or I can do the 4 on the middle. So, and this is the other thing that I want to mention, and it's the same for the first one as well. You may have multiple answers for a single question. You may not have a unique question, but both of them are correct. So A and B both are correct for the one we solved previously, this one. we have y prime, w prime plus yz. I'm sorry, w prime, yes. And you can see we can combine them in different ways and both of them are correct. Why are both of them correct? Because both of them have the same number of literals, so it's minimized. If, one of was smaller, but, you can see that both of them are in optimal. Both of them are correct. Sometimes you don't have a unique question and unique answer for a question, and both of them are correct. And it's the same thing we had before as well. Okay. So the NAND and NOR implementation, I think it's enough for today up to this point. Because if I start this, it's going to take like half an hour to an hour to complete this. We're going to go to the lab and finish lab number 2 today. I wanted to give more time to the lab because you have more to do for today's lab. And yep, that's it. Thank you so much. And I'll see you on Thursday for the online students.